Hello and welcome to Problem Solvers. My name's Matt. Every month the museums of the University of St Andrews will bring you problems to solve from the past and problems to solve from the present. Last month we found out about chemist James Irving and his problems with sugar. We set you your own chemistry problem asking you to put different colours of water in the same jug without them mixing together, and we met real-life chemist Yi-Ying, who asked you to work out how to join molecules together in order to make bendy mobile phones. So the problem I set you to solve last month was to combine 3 different colours of water in the same jug without them mixing, and I gave you a clue: you need to use sugar. Well, this is how you do it. First, you'll need boiling water, so get an adult to help. In one colour, I want you to put 5 tablespoons of sugar and make sure it's mixed together really well. In the second, I want you to put 2 tablespoons of sugar. And again, make sure it's mixed together really well. And in the third, no sugar at all. Now, let's put them together in this glass here and see whether they mix. First, the green with 5 tablespoons of sugar. Then, slowly add the red to the top of the green. And you can see the red is sitting on top of the green. Try adding the yellow yourselves at home and see what happens. It will stay on top of the others. So why does that happen? Well, it's all to do with density. The more sugar you put into the same amount of water, the denser it is, because there are more molecules in there. So that's our coloured water chemistry problem solved, but what about our bendy mobile phone problem? Let's speak to Yi-Ying again, our real-life chemist, to find out what the solution is. Yi-Ying, hello again, how are you?
Hi, not bad, but I still haven't chance to go back to my lab, so I'm afraid that I cannot show you around my lab today.
That's a shame, but I understand you've got some pictures for us.
Yes.
Fantastic. Now, last time we spoke to you, you told us about a material that's 1,000,000 times thinner than a human hair called graphene, which is a single layer of the graphite that you find in your pencil. You told us that you need to stick these molecules of graphene together into strips that can help us make all sorts of things like bendy mobile phones. And we have a few suggestions for machines that could stick them together that people have sent us. Would you like to hear some?
Yes, of course. I'm so looking forward to hear to that amazing idea.
Fantastic. So a few people have suggested using tiny glue sticks to stick the molecules together, and one person has even suggested that you could pay ants to glue the molecules together, which is an interesting idea. Would glue be a good way of sticking these molecules together?
Yeah, so well, in the lab we don't use glue because a drop of glue is even larger than the size of our molecules, or we call it building blocks.
Okay, and have you ever considered using ants to do the work in your lab?
Yeah, I also think that it's really smart to ask ants to do the lab work for me, but the problem is that I cannot communicate with ants, so if someone knows how to do that, please teach me and I can learn it from you.
Maybe that can be a future problem solvers. How do we communicate with ants? So can you tell us how you stick these graphene molecules together?
Yes, so in the lab, we use, I put some building blocks onto my metal surface. Then I heat up the metal surface. When I heat up the metal surface, the building blocks, they will be more flexible, so they will move around. And the way they like to arrange is to arrange to a chain-like structure. If I heat up more, then those building blocks, they will link to each other, then I can form my ribbons.
Fantastic. So the heat makes them move around into ribbons, and then how do they join together? Does the heat melt them, or do they join together in another way?
They will kind of bump into each other.
And you use this amazing machine that we can see now to do that. It looks like a really cool machine. Is it difficult to use?
I would say it's not that difficult. It's pretty much like playing claw machines. Do you know claw machines?
So that's like in an arcade where you control the claw to pick up a teddy bear or something like that.
Yeah, that's right. So for the claw and move on top to the toy I want to pick it up, and then pick up the toy. And then I need to move the toy to a box and then drop it into the box. Then I can have my toy. But for our machine, we use a tip and then we control our tip to move to the top of the molecules we want to pick it up. Then we pick up the molecules, then move it to the place we want to drop it and drop the molecules. So I would say it's not difficult, but you need a lot of patience to keep trying until you succeed.
And the machine looks a little bit scary. Is it dangerous?
If you know what you're doing, then I would say it's not dangerous, but there's one thing I would like to mention. So we keep our machine at a very low temperature. If ice is at 0 degrees, our machine is at minus 220 degrees.
Wow, that is cold.
Yeah, so to keep the temperature, we need to transfer a liquid that is minus 220 degrees into our system. So to do that, I need to protect myself. So I need to wear gloves and goggles to make sure I will not burn myself.
Wow, because things that are really cold can burn you just in the same way that things that are really hot can burn you.
Yeah, that's right.
Fantastic. Wow. Yi-Ying, you've made chemistry sound really quite cool. I think I want to be a chemist now. Thank you very much for your time and for speaking to our problem solvers. Goodbye.
Bye.
And there we go. Join us again next month for another set of problems to solve.